You do math now. You math. Math. We're on it.
We are on it. Be quiet, guys. Get on it. Get on that. We're on it.
Four, 8, 12, 14, 17, 20. Full house. Anyone still going? Okay. Option 1. If y is stuff, replace y with stuff. Subtract things over and you get x squared minus 16 is 0. Or elimination. Negate, negate, negate. Negating the y's, negating the x's, and getting a negative 16. So it doesn't matter which way you take, substitution or elimination, you're going to get to the same place. All right, once I'm here, solving isn't too bad because it's a difference of squares. Or you could just add 16 to the other side and square root. Like, same difference. I get 2 x's, better find out why. Y is going to be a negative 4 plus 4, and y is going to be a positive 4 plus 4. Getting 0 and 8. Don't just do that. Make sure you run it all the way in and say 4, 8, and negative 4, 0. Okay? So, did you substitute or eliminate to get to one of those, blue or green? Did you substitute or eliminate to get to the quadratic? Did you solve said quadratic? Did you plug it into both y's? And then did you get the 2 correct coordinates? Meaning not just you wrote your answers as coordinates, but you wrote them correctly. You have the correct terms paired. Like, oops, I said negative 4, 8. And, comma, whatever. It's the same thing. It just means and. It's and for lazy mathematicians. Anything about that? Okay. You can go away. Where's oh, I never brought it up. Homework. Talk to me, Goose. Pearson. There we go. There we go. Come on, you.
Oh, this morning.
There he is. Boy, that's taken a while. Boy, that's taken a while. There we go. All right. Something? Anyone? 38? Graph the solution. Okay. Let's do Word. View page with. There we go. All right. Get a little room to work here. There we go. There we go. That's more like it. Okay. First one. Negative b, 2a. Negative 1/3 squared is 1/9. 1/9 by 3 is 1/3. 1/3 plus a negative 2/3 is a negative 1/3 plus 1 is 2/3. Question mark? Yes, no? Third, 1/9, 1/3, 1/3 minus 2/3 is negative 1/3, negative 1/3. Yeah, it is. Okay. Back a third, down 2/3. Meh. Right about there. First parabola. Up or down? And perfect squares are going to be multiplied by 3. So from that point, what? That's why I'm asking. No one's paying attention, which really makes me not want to do this. So, is the function of negative 1/3 2/3? Negative 1/3 squared is 1/9. 1/9 by 3 is 1/3. Negative 1/3 times 2 is negative 2/3. 1/3 minus 2/3 is negative 1/3. Negative 1/3 plus 1 is 2/3. Perfect squares by 3. Over 1 up, not 1. 1, 2, 3. Over 2 up, not 4. 12. So it's a skinny mini. Solid or dotted? That's ugly, but whatever. Then do the same thing for the other. Negative b over 2a is a positive 1/4. Plug in 1/4. 1/4 squared, 1/16 by 2, 1/8. 1/8 minus 1/4 is 2/8 is negative 1/8 plus 1 is 7/8, question mark. I was woken up by a screaming child in the middle of the night. Someone check this. One-fourth, 1/16, 1/8. 1/8 minus 1/4 is actually 2/8. So 1/8 minus 2/8 is negative 1/8. Negative 1/8 plus 8/8 should be 7/8. Okay. So 1/4, 7/8. 1/4, 7/8. Nah. About there. And perfect squares, but doubled. Over 1 up 2. Over 2 up, not 4, 8. And then mirror, also dotted. Yellow says shade inward or outward. Which is it? If y is less than the parabola. Right? Less than the parabola. And blue says greater than the parabola, so I will go this way. And it's going to be that sliver in between. Okay? But not like that. Let's put this away because neither of you doing work, so stop it. Okay? It's just about graph it. And honestly, if you're going to graph those, there's nothing stopping you from just slam it in a calculator, graph by table. Put it in a calculator, calculate the minimum of each. Use that to find your vertex, plot by points. After that, it's just a matter of dotted and shading. Okay, don't overthink them. If I'm going to be cutting down the assignments, if I'm going to be trying to narrow this down to 5 or 6 problems, I'm also not going to come in here every day and do 2 or 3 of them. Because if I'm doing half the assignment up here at the beginning of class, what's the point in having the assignment? Ask questions. You got a tutor in a pocket. No other math teacher does that. Okay? Just not saying that you can't ask this question. I just want to put that out there. If we're going to cut the assignments down, I need to have a little more engagement. Don't be afraid to come in for 10 minutes in the morning and ask that question. Don't be afraid to text me at 11 o'clock at night. I might not be conscious. I'll answer you at 5:45. Okay? But you will get your answer. Come in during Spartan time instead of just leaving because you can. Like, use the resources that are available to you. All right. The other one, I know someone was going to ask because a person asked because I intentionally grabbed the ugliest one I could find. Dawson, do you mind if I pull up that? Okay. Okay. To solve a system, you say y equals this junk, replace y with that junk. What was this, like 40 something? 48? Okay. You replace y with junk. You get the quadratic, you solve the quadratic. This quadratic could not be factored, so complete the square quadratic formula. I figured you wanted quadratic formula. But then your answers are ugly. That's okay. 7 over negative 7/5 plus 2 root of 11 over 5 is still an x. I can still plug it in for x to get the y. The y is just going to be ugly too. That's it. The answers were these two but ugly compound number coordinates. If you can do that, you should be able to annihilate anything remotely related to quadratics for the rest of eternity. Okay? That's some tough stuff. Like, if you struggled with it, if you got ugly numbers and had to maybe text one of your classmates and, are you getting this stupid thing over here too? If you had to text me and ask, am I doing this right? If you had to check the solutions online to make sure that you were doing it right. Great. You are engaged in the learning process. You are double checking your work. That's what I wanted you to do. Okay? But it was a doozy. The process was the same as everything that we did. Our daily quiz was this exact same process. It just didn't have nasty numbers. Okay? So that was the one question I was asked. Sounds like we still need to practice graphing. What else? Okay. Then, not you. You. Come on, Frank. All right. All right, folks. We are at the heart and soul of Algebra 2. Chapter 5, I ain't going to lie, it's the toughest. Okay? Because now we hit new stuff. Everything that you've done so far has been review or a one-step expansion of what you already know. Like, we did all the junk about systems. You did that in Algebra 1. All I did was add in what happens if you have 3 variables. Well, you turn it into a 2-variable system and move on with your day. Okay. You did absolute value graphs back in Algebra 1. You did them by table, though. The idea of using transformations to move them around was new. We just added that one step to it. Quadratics was basically what Algebra 1 was about. All I did was add in imaginary numbers. So we've just been taking the stuff that you knew and sprinkling a little bit on there. Okay, a little grated Parmesan cheese, call it good. Now we're going to take polynomials. Now, like just like in geometry, you spent so much time on triangles because every other polygon could be turned into triangles. We spend all this time on lines and on quadratics, on equation manipulation, because now I can move into cubics, quartics, quintics, hexics. Actually, after a certain point, we just kind of give up and start calling it a degree n polynomial, which is actually what today is about. Today is more about vocabulary, so it's actually pretty easy. But the chapter 5 that's the meat and potatoes of Algebra 2. Like, you have to know chapter 5 to move on. If you want to go on to college algebra, dual credit, you want a degree in anything, literally, a associate's in childcare, you need college algebra, okay? Which is just this class again. Or if you want to come up to pre-calc, which is past college algebra, you have to know how to do this stuff. So chapter 5 is super, super important. Honestly, after 5, it's just kind of a mishmash of different types of functions that aren't really related to each other. And it's almost like a coast to the finish line. But so you know where we're at, or what we're doing here, we're just starting 5. Ignore when the quizzes are, like those are all out of sync. Last year I was going like 4 days of instruction and then a quiz. I just shifted it to 5, so that's why everything's always off. Chapter 5, we're going to be in for about 3 weeks. It's a big one. That's why that's a big honking packet. Okay? It's a big one. Then, yeah, that was just chapter 5. Okay? So it's about 3 weeks worth of unit in that packet. So that's why it's so thick. After that, 6 is radicals, which is, again, just expanding on what you learned in Algebra 1. But then we're also going to toss in function manipulation in there, like inverses and compositions. That's new, but it really is just... If you liked Algebra 1 because it was, I move letters and numbers around, and I can do that. Like, I don't really have to think. I just have to move letters and numbers around. If you liked that, you're going to love Chapter 6. Okay? After 6, so that's November. Come on, you. We're at the halfway point, so that's why we're talking about this. Tomorrow is the quarter. After 6, so we'll be into December when we hit 7. 7 is exponents and logs. It's not difficult. In fact, it's actually pretty simple. Most kids like that chapter because it's just, okay, I put this number here. Ta-da! And then some basic properties. We're doing okay for time. Like, y'all are actually doing okay for time. After the logs, my plan book stops being correct because you're the first class where instead of spending a good chunk of time on probability and statistics, since most of that you saw back in Algebra 1, and they assume you know it, we are instead going to, oh wait, no, I'm doing after 5, in between 5 and 6. We're going to do rational functions. Rational functions after chapter 5 should be fairly quick and easy, like a week, week and a half. which means I don't know that we're actually going to get to prob stats. So your class is literally the first that is doing rational functions in Algebra 2. Because we need to get it out of Algebra 1. It hurts kids. If you don't remember what rational functions are, it's like what happens if I say solve. See, the bummer of that is you did that in Algebra 1. And most kids block it out of their memory because it was a traumatic experience. Okay. So you're going to be the first class that we do that in Algebra 2. Like this year is actually the transitional year. This year, our Algebra 1 classes, they did 3 variable systems. They're going to do standard deviation in their prob stats unit so that we can take rational functions from Algebra 1 and bring it up to Algebra 2, where immediately after this big honk in Chapter 5, it's going to be a breeze because you're just going to factor the bejesus out of things. Okay? So, a lot of stuff coming up. We're at the halfway point. Once I put in those last 2 quizzes, again, I told you I graded quiz 5 the night you did it. It went very well. I just haven't put it in campus. Y'all did great. Quiz 6 we just did yesterday? 2 days ago? 2 days ago? I'll get it in when I can. Like, I'm scrambling just to get the books done, the notebooks. So a clean break at 5 for the quarter. We will do 5, 9, 6, 7 after starting now. So it's a lot of stuff to get through. Being in a transitional year like this where we're switching around curriculum, you have the dubious honor of we're trying to cram in an entire extra chapter in the same amount of time. So the vast majority of you are signed up for pre-calc next semester. This means you're going to crush it because you're going from Algebra 2 straight into pre-calc and you're going to have done rational functions. So you are going to be probably the best pre-calc class that I've ever had, if that happens. Because I have to review rational functions in pre-calc because kids haven't seen it in 3.5 years. So that is where we are at. Here we go. All right, let me get a poll in here. Where's my juniors at? 1 potato, 2 potato, 3 potato, 4, 5. Oh, it's actually more than I thought. Okay. We're already talking about registration and stuff among teachers and course offerings. If you are in 10th, it is recommended Algebra 2 straight into pre-calc. 11th, take trig. 12th, take calc. Unless you are going into a STEM field. If you are going STEM field, I would instead say 11, do trig and calc. Then, your senior year, you have the option of either doing dual credit calc, which is going to be pretty much the exact same thing, but easy A, and now it's for college credits. Or you go Calc 2 dual credit from the college. That's hardcore math right there. Do not go back and take college algebra. It's a giant waste of your time and money. You will test out of it. Pre-calc goes, like, college algebra is Algebra 2.2. Pre-calc, literally, when I took it in high school, was called Algebra 3. It's an entire other course past college algebra. Okay? It's a waste of your time and money. Juniors, if you're in Algebra 2 right now, depends what you want to do with your life. If you just want to graduate and get the fornication out of here, you're done. Take your ACT immediately after this class. If you can, sign up for dual credit college algebra next year. If that's what you want. If you instead want to do, you want that Regent scholarship, like it's the Regent and Opportunity Scholarship, then you probably want to go to pre-calc next semester and then take your ACT immediately after that. That is the highest you're ever going to get on an ACT. If you do a full year of Algebra 2 into pre-calc as your junior year, like that's the highest you're ever going to get on your ACT for the math portion. And now that you guys have super scores, you're going to be good. Okay, the questioning looks. Back in my day, you take your ACT and it is what it is. You don't like your math section? Take it over. Whatever you get the next time, cool, that's your score. You submit your ACTs every time, and they're just going to take whatever your total composite best score was. So if you, for example, get one wrong on the math section because you forgot what summation was, and then you go and take it again and get one wrong on the English section because you can't read, you got a 35 both times. But under the super score system, they take your highest score in each category each time you take it and put it together. And under a super score system, if you get a 24 in the math this time and you get a 21 in the math this time, they're going to keep the 24. So that's why I say immediately after your junior year math, immediately after pre-calc, if you're going to go on and do it as a senior, take your ACT. ACT immediately after your junior year math or pre-calc, whichever you're doing. Please. Okay? Now, for our sophomores who are on that accelerated track where you're going to do Algebra 2 and pre-calc this year, then as a junior, trig and maybe calc, you're going to have to go back and review a lot of stuff because trig and calc deep dive on a subject. It's kind of like how much algebra did you forget being in geometry? Right? All of this quadratic stuff, how much of that did you forget in geometry? Because you deep dive on a particular subject. That's going to happen to you again if you keep going on to trig and calc. I have done math that would just make you crap your pants. I forgot every bit of it. I don't know anymore. I haven't touched a differential equation since literally 2004. As long as you've been alive. So, just saying. Yeah, please talk to math teachers about what you're going to do for math. Just like, don't talk to me about what English classes to take. Go talk to an English teacher. If you got completely bamboozled and didn't take geometry, then get that taken care of. So, here we go. Vocabulary. The whole lot of you are either in or have taken biology. You all know of the term binomial nomenclature. Okay, binomial nomenclature means two names to name things. Bi meaning two, nomial meaning term. Two terms to classify a thing. We use that in math as well. Some examples. If I have a degree 0, well, that's like, well, x to the 0 is what?
1.
Everyone grab a calculator, type 5 to the 0, 7 to the 0, negative 25 to the 0. Well, you're all saying different things, so figure it out. 1. Okay. So if that is 1, well, then if I have like 9, x to the 0, I just don't write this because it's 1. It's just straight up 9. 9 no longer has a variable, so it is called a constant. It is called a constant because it has no variable anymore. Its value can't change. An example of that is just the number 62. Ta-da! Y equals 62 is just a horizontal line at 62. I can name things two different ways, by its degree and by its number of terms. If something has only a single term in it, one term in it, I would call it a monomial. Mono meaning one, nomial meaning term. Monomial. You ever see that feature on your headphones, on your computer, on a TV, mono versus stereo? Okay, mono means a singular output to both speakers. One output. All right, if I have x to the first. If I got x to the first and it's got two terms, so that would be like 3x plus 1. What is that called? What type of function?
Binomial.
It is a binomial, that's by terms, yep. It's got two terms, binomial. But what about by degree? What would the graph of that look like? It's a line, so it is linear. Okay, it is a line, so it is linear. The one that we just spent time on, degree 2, quadratics. Now it asks for an example that has one term, so that'd be like negative 2x squared. That is again a monomial. The point of that is to show you that you can have monomials that are constant, monomial lines, monomial parabolas, monomial cubics, all that kind of stuff. Oops, I gave it away. Degree 3, cubic. Three terms is trinomial. Okay, so that'd be like x cubed plus 5x squared minus 9. Three terms. I'm just making stuff up. Okay. So x cubed plus 5x squared minus 9, I would call it a cubic trinomial. Cubic means degree 3, trinomial means three terms. Anyone know degree 4? Can we follow this pattern? Something ick? Quartic. And then a quintic. And then it's just and then it's just going to keep going. Technically, you can then go to a hexic, a heptic, an octic, a nonic, a decic. Okay. What a dodecagon is a 12-sided, right? But a duodecagon, 20. Duodeca. Duo, 2, deca, 10. 2 tens, 20. Okay? You can keep going with this, but here's what we're going to do is, honestly, at 6 plus, we're just going to say a degree n polynomial. Meaning, whatever number is up front, it's that. So at 6, we usually just start getting lazy and say a degree 6 polynomial. Okay. Two-term quartic, that'd be like x to the 4th plus 16. I don't know. Another binomial. Okay. Similarly, when I hit degree 6 and later, I just get lazy and say it's a degree n polynomial. Degree 6 polynomial, degree 7 polynomial. Even though they have technical terms, we don't use them after a certain point. Just like after a certain point, maybe after a certain hour, you get tired and you just say, that. You just stop thinking. I actually went to a cafe once that had the entire menu was just pictures. That's it. It was just pictures and then there was the price on it. There was no description at all. And the title at the top of the menu said, "It's 2 a.m., you're drunk, just point." Like, that's a cafe that knows their clientele. After a certain point, you just stop caring. When I hit 4 terms or more, I could call it a quadrinomial. I could call it a pentanomial, a hexanomial. Hept and sept are both 7 prefix. In American English, we usually use hept because septic has a different meaning for us. Septic meaning of waste. Well, no, just of waste. That's the one that you're thinking of. Have you ever heard of someone who gets sepsis? Blood poisoning. Sepsis is when waste material in your bloodstream collects in your bloodstream and starts poisoning you. Okay? But at a certain point, we just give up and we start calling them polynomials. In fact, let's put 4 plus. At 4 plus, we just kind of give up and start saying polynomials. Now, technically, a monomial is still a polynomial. It's kind of like all thumbs are fingers, but not all fingers are thumbs. Everyone's like, wait, what? No, slow it down. All thumbs are fingers, but not all fingers are thumbs. Okay? All monomials are technically polynomials, because polynomials is the umbrella for all of this stuff. Because if I had a monomial like x to the 4th, that's one term, right? Mono. But doesn't it have a 0x to the 3rd, 0x squared, 0x plus 0 after it? We just don't write it. Okay? So that's why all of these are under the label polynomial functions. Now, the reason you have to know all that is because I'm never going to be the guy that puts vocabulary on a quiz. like fill in the blank, matching, anything like that in math. I'm not going to do that. But you got to know what it means, or else you don't know what the crap they're asking you in the directions. So write it in standard form and name it by degree and number of terms. In like standard form. Just take a look at what they got there. What do you think standard form means? Okay, you said what it's going to be. Now explain it. Okay, that's specifically quadratics. What about when it's a quartic? There you go. Think about it like the movie theater buckets, right? Right? Like the movie theater buckets or the different Slurpees at the gas station. You want it to be in biggest to smallest order. Because technically there's an x to the first and an x to the 0 here. 2, 1, 0. Okay? That's what standard form is. So, first of all, who's the big dog? Who goes up front? X to the fourth. You still need to combine like terms, too. Now that I have put it in standard form, both of these, let's name them by number of terms and degree. The first one has 3 terms. So it's a trinomial. What is the degree of it? So it's called a
Quadratic.
So I would call it a quadratic trinomial. Why don't I call it a trinomial quadratic? It doesn't sound right. It doesn't sound right because quadratic is when you put the IC suffix on there, it can be used as an adjective. A quadratic can be a noun, but something that is quadratic, now it's an adjective. Okay. What about this one? There you go. All right. Clean them up and give them a name. It's like finding a stray cat. Henceforth you shall be Cuddles.
Yeah.
Okay. Combine like terms. After you got like terms, these are wrong. Combine like terms where you can. Put it in descending order of exponents.
We still never got it really fully. She's still mad at So did you, and so did he. Although not as much as you.
All right. See, it turns out that in all of these polynomials, it's kind of like that leading term. The term that's in front, that would be like the person in your friend circle who dictates what happens. Okay? That would be the gal who says, "We're going to go to the movies. I want to see Dune." And maybe some of the other girls are like, "You know what? I don't really want to. We're going to go see Dune though." And then they say, "All right." Okay? They have decided what is going to happen. The same thing happens in polynomials. The leading term tells me end behavior. Okay, end behavior. Think about it in terms of the school year. At the ends of the school year, you have a particular kind of behavior. Most kids coming in at the beginning of the school year, they are actually fairly excited. You get to see people. You get to be around people, assuming that even if you hate 90% of the people you're around, maybe there's those 3 or 4 you're still excited to see. Okay? Versus by the end of the year, you're either completely burnt out and get me out of here, or you're excited because, yay, I get to go do summer thing. Whatever. At the end of the year, you act a certain way, right? This graph is going to act a certain way all the way to the left and all the way to the right based on the leading term. I don't like this at all. They call them up and up, down and down, down and up, and it sounds very childish. We are going to get rid of this because this is the only textbook I've ever seen write it like this.
Or we call it a W. Words. That sounds more
Okay. When I look at my leading term, I'm going to call it ax to the n. A is the coefficient in front of it, n is the degree. If I have a positive even polynomial like y equals 3x to the fourth blah, 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 stuff. Yup, because their chart is trash. I don't know. Oh, not you. You. There we go. If I have 3x to the fourth and stuff, it's going to start up here, back at x is negative infinity. It's going to be up at positive infinity. It's going to come down, do stuff, and then head back up to positive infinity. I'm going to treat that almost like a coordinate. I want to get you ready for either ACT, college algebra, or pre-calc. There's something that we call limits. I'm going to give you kind of a shorthand notation of it right now. What I'll say here is as x goes to negative infinity, my y's are at infinity. As x goes to positive infinity, my y's go to positive infinity. Almost like a coordinate. As my x's go all the way to the right, my y's will go to infinity. That is its end behavior. As you get closer to the end of the year, you will get happier. As we go all the way to the left, the closer we were to the beginning of the year, maybe you were happier. This, you know what? This is a lot of kids. I'm kind of excited getting into the year. You get into the grind, and then the end of the year. Okay? If I have that same thing, remember our transformations? What do you think would happen if that was a negative 3 x to the fourth, blah, 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 blah? It would flip. That's exactly what happens. Okay, you would have a vertical reflection where x is negative infinity to positive infinity, our x-axis. My y's in both cases went down to negative infinity. So if I write that as my kinda coordinate here, my end behavior, I'm going to say as x goes to negative infinity, as my x's go all the way left, my y's go down to negative infinity. As my x's go all the way to positive infinity, to the right, my y's are headed down to negative infinity. Okay? End behavior. If I have this kind of polynomial, it's going to do this at the ends. What it does in the middle, well, that depends. This would be the kid who absolutely hates that they have to come to school at all. But then as the year goes on, you're around people you enjoy, so maybe you are doing all right. Maybe you meet that special little someone. And then at the end of the summer, oh no, they move. And now I have to go to mom's house and I'm just going to be miserable for the next 3 months. Okay, right? Your end behavior at the ends of the function, the ends of the school year, it's going to do this thing. With odd functions, they behave differently. If I'm like 2x to the third, blah, 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 blah. In an odd function, they always start and end in opposite places. So a positive will start down at negative infinity and end up at positive infinity. This is the kid who maybe moves into the district absolutely peeved at their parents because they had to move. And they hate everything and they just want you all to die. You know, insert emo memes here. And then by the end of the year, they're like, I love it here. I have so many friends. Negative infinity. Oh. Oh. So how would I write that like the others? As x goes where? As x goes to negative infinity, the y's go down to negative infinity. As I go all the way to the right, as my x's go to infinity, my y's are also going to infinity. So what do you think is going to happen when we have that odd function, but now it's got a negative out front? Same thing, we got that reflection. What it does in the middle completely changes based on the rest of the polynomial. But back here at negative infinity, well, it's up at positive infinity. Back here at infinity, it's down to negative infinity. Write those as your coordinate. As x goes to all the way to the left, negative infinity, my y's are going to go all the way up to positive infinity. As we go all the way to the right, x's are going to infinity, my y's will go to negative infinity. Now, this is a more detailed version. This is a hyper-detailed version. Okay. I'm about to make it, but smaller.
Oh, okay, that's fine.
That was for the discussion. The thing that you absolutely need to have written is I'm doing a much smaller, less detailed version. Just the end behaviors. As x goes to negative infinity, as x goes to positive infinity. As x goes to negative infinity, as x goes to positive infinity. As x goes to negative infinity, as x goes to positive infinity. Every one of them had this. Every one of them had this. All of this stuff right now, that's just, I look at the graph, I'm either going left or right. If it's a positive even, they both go to positive infinity. I'm just reiterating it. If it's a negative even, they both go to negative infinity. If it's a positive odd, it starts negative, ends positive. If it's a negative odd, it starts positive, ends negative. So that's the kid that's super excited to come to school, and then all their friends turned on them, and there was all kinds of social hellfire. And by the end of it, they just want to move. That's it. Okay? The reason that I want you to get used to this is in pre-calc, we talk about limits. And we say the limit of the function as x is approaching infinity is infinity. Do you see how the notation is very similar? So a couple years back, me and Mr. Spear made a concerted effort to start using this notation in Algebra II, because the book uses this childish up and up, down and down kind of wording. We would rather use this, so if you don't go on to pre-calc at the least, you'll have seen something like it, and hopefully you'll remember that on a standardized test. Okay. It's a lot of talking for something very simple. Get on there. There we go. It worky like this. Ew. Use our notation instead. Gross. Consider the leading term of each polynomial. What's the end behavior? And it even says you don't have to know how to graph this on your own. Just check it on graphing calculator. So first, is it in standard form? No like terms to combine. In descending order. Okay. So since I see a positive x to the odd, then I'm just going to go look at my little chart and say, if it's a positive odd polynomial, it's going to start down here, do stuff, and head up there. That's just what positive odd polynomials do. It's kind of like if you see a bunch of guys who are going and keep hitting each other and using words like alpha and beta as adjectives, then you know that they're probably full of toxic masculinity, and they're not going to have any open mind about treating a girl like they're supposed to be treated. They're instead going to conform to, I ugh, hit girl, drag to cave. So,
That's why Dawson doesn't say alpha.
because he's a good guy. Enter psychology and sociology in college. You will learn that everything I said was true. I know that as x approaches negative infinity, my y's will go all the way down to negative infinity. I also know that as x goes all the way over to positive infinity, my y's will go up to positive infinity. That's how I'm going to write my end behavior. It looks goofy, but once you understand the symbols to it, it's not that big of a deal. Case in point, every semester I have to learn an entire new vernacular because kids' language changes every semester.
That's true.
It's not even every school year, it's every semester. Is this in standard form? No like terms, descending order. Okay. I look at my leading term and I see a negative x to the even. Go back and look at your chart. Negative x to the even. Okay. When I see the kid with the fake Southern accent and the belt buckle in South Dakota, I know that they probably subscribe to certain cultural norms that do not include the, human rights of other people. When I see this type of thing, I know how it's going to behave. I know as x approaches negative infinity, my y's are also headed down to negative infinity. As x goes all the way to positive infinity, I know that this thing is probably going to negative infinity. Because every negative even polynomial starts down here, does stuff, and goes right back where it started. Okay, that's just what end behavior does. This is called the leading term test. Okay, now, just like everything that I said, isn't every bit of that a stereotype?
Yes.
Isn't every bit of that not true in all cases? Okay, with polynomials, because it's a very specific subset of math, it's always going to follow these rules. As soon as I throw a radical somewhere in there, as soon as I put an x on a denominator, as soon as I have a x in an exponent, it changes the behavior, and this stereotype no longer works. Case in point, you probably would not get it anything remotely right if all you saw was a picture of a fat white dude with a buzz cut in South Dakota and thought you knew me. Not even close. I don't get along with 90% of the people I'm around. Okay? In math, you can do that. With people, you can't.
Because it's 3, not 4. 3 is odd. 3 is odd. So used.
Okay? Question. What is 0? Odd or even?
It's infinitive. Undefined. It is undefined. We should never have to work with that.
It is even. The definition of even is anything that is divisible by 2. 0 divided by 2 is still 0.
But 0 divided by 1 is 0.
Yeah.
And then have to know what line it is.
Just because it meets one definition doesn't mean it can't meet another.
Yeah, and then it's flip some. So when the first one's negative, positive.
Just because it's a teenage male who hits each other and goes and uses the word alpha and beta doesn't mean that they're a horrible person.
That's true.
It means they're around other guys that do that, and you have a cultural homogeneity.
That's fact. It's just part of being an alpha.
It's really not. In fact, by definition, it's following.
You a follower?
Because you're picking up the behaviors of the others. So when you call someone else that, you are literally following another person's behaviors. Everyone who says alpha like that is following someone else's behaviors and therefore they are a beta themselves.
Yeah, CK. Why are you saying me? You're the one that said alpha earlier. You said it too. I said that's part of being alpha.
It means you all are.
So you're following me. No.
So, this one. I see a negative x to the odd. I know that as x approaches negative infinity, where's this thing headed? Positive infinity, all the way up. As x goes to, do you know they have a Lightyear movie coming out? Like Buzz Lightyear's origin story is a movie that's coming out. It's going to be so cool. They got Chris Evans to do the voice. Captain America is Buzz Lightyear. So. All right. We do have some stuff to get through here, so lock it back in. Okay? Graphing them. There are tricks to the trade. We do not know them yet. So what do I do to graph anything I have no freaking clue how to graph? Dump that in a calculator and plot by table.
There's not a single.
Oh,
See any lines.
okay.
That's the problem.
So you're just going to have to kind of wing it because when I hit the copy button, I can do the grayscale shifting, and I bring it down a little bit because some pictures you can't even see because it's just a big black smudge. This is the consequence. Sometimes we just make lines disappear. All right, let's have y'all do this one. Okay, just do that one. Can you plot that by points? I know that you can't see the lines the way that it printed. Wing it as good as you can. Remember all the way back to the beginning of the year when I said, you can graph anything by table, but I will never make you write the table anymore. Okay, instead, okay, making sure I got it right. I typed something into Y1. How do I get my table? What?
Negative 1 is negative 2. Negative 1 is negative 2. What do you mean? Not in this
Standard form?
It's going to get
Like, does it matter?
All right, y'all are too loud. Listen to the brook. Say that again.
Does it have to be in standard form?
Does it? If you're plotting by table, what are you doing? Like, I know we're just pressing buttons on a calculator, but how do you actually plot by table? What about coordinates? How do I get them? Okay, you plug in a number. If I plug in -1 for x in this versus in this, will I get a different answer? No. So they should be the same thing, and I can prove it by, I go to my table, they're the same. But that's a really good question. If we're writing out an equation, we usually want to put it in standard form. If you're just jamming something in a calculator, that is not necessary. Okay, so this thing gets really funky really fast, doesn't it? Okay, what I would like you to do when you plot these. You don't have to do this. I'm just doing this to show something. Okay. When you plot it, you plot those points, right? How would you know how to connect those if you didn't see the graph itself? Okay. We have used the table set feature. So,
I was just gonna say you could tell if it's like sum of, or like you could tell what kind of graph you want.
all right. Oh, I didn't hear. Okay. The end behavior, right? The end behavior of the graph, if I know that there's an x-intercept here, if I know that there's a point here, a point here, a point here, a point here, that's just like garbage. But if I know my leading term, my end behavior, I know that this has to start up at infinity and end at negative infinity. So it must come down through there to get to my end behavior. So you plot the points that you can find, and then that. Another feature you can use, maybe you want to get a little more detailed. I'll go to your table settings. Remember where we always switch it over to ask mode?
Dependent.
No, look at this. You two should really stop talking because this is important. A little triangle is delta. Delta represents change. This is the change in the table. I can tell the table to go by halves. So now when I go to my table, it's going to go by 1/2 intervals, meaning I'll get more points. If I got more points, the likelihood that I see the curve to it is greater. Instead of just, there's a bunch of stuff on the paper. Like, it's a scatter plot. What the crap is this? No, instead, now I'll see more points. Okay? So, I'm assuming you all got the thing. You graphed the guy. Describe the graph, including end behavior, turning points, increase, decrease intervals. So if I got something like this, I'm just, winging it, right? End behavior. I would say as x approaches negative infinity, what is y doing?
To infinity.
As x approaches positive infinity, what's my y doing? Okay, so that's end behavior. Turning points. How many times did it change direction? 2. So I'd say 2 turning points. Increasing and decreasing intervals. That's trickier. To do my increase and decrease intervals, this was at x is -1, right? This was at x is +1. So when I say increase and decrease, I'm talking about as I travel from left to right across the x-axis, is the graph headed up or down? So as I come at it this direction, aren't I headed down? Down, 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 and then it's increasing, and then it's decreasing again. So when I state that as an interval, I'm going to say that this thing was increasing from -1 to 1. I state my lower boundary and my upper boundary. You're not looking at the y values. As x went from -1 to 1, the y's went up. It decreased right here. Well, what's the left boundary then? What's the left boundary? Negative infinity. So it decreased from negative infinity all the way until I hit that 1, or sorry, -1. And it also decreased from 1 to infinity. And if you remember from geometry, I can throw what's called a union in between them. It's like a big old U with some junk in the trunk. Okay? It says both of these.
Could you do like a care sign or a comma or anything too? Or does it have to be a
For now, I'll take it.
I never said it was
What?